Okay, so the last time that you guys saw us, we were kind of transitioning over from our old spiral design into the new design that we created, and we kind of talked about, how we came to come up with that new design, decision matrices, sketches, our product life cycle, and all those really important things. And now we're kind of just going actually building the system and implementing all those things that we talked about before. And one of the things that was really helpful was our expo book, and we read our expo book 2 this time around, and that was Hydroponics by Mark Bennett. And this book was really more in depth, and it really helped us talk about creating a hydroponic system and maintaining it. We really took away kind of like how to deal with the plants in the system, how to prevent pests, what to do if it came up with problems, and kind of just like daily maintenance, monthly maintenance, weekly maintenance, and just all those important things that we need to do when it comes to a hydroponic system.
All right, so for this this presentation for our mockups and prototypes, we actually have changed from the old one, which was the square, but like the sides were kind of indentured inward, so it didn't cover the outsides. So from this way, we've moved on to our next prototype, which actually limits the amount of water flow we have to create more of a balanced water flow table. And we also extended those sides out to cover for actual siding. And there'll be a picture on screen right about now. And that'll help with the water management, as well as some other issues we had with the siding not being able to be put on.
But I mean, it sounds like y'all are making really great progress. And I mean, the budget thing is clutch, because that allows you to just any margin you can get. If plants die, if things burst, or whatever, you have a little bit of a wiggle room with it. So, yeah, and I guess you're a couple months out, right? You're a month and a half-ish out from the in-house, and then about 2.5 months out from the expo. So
yeah. It's crunch time.
It is crunch time. I would say think about some like little like mini milestones. They don't have to be like hard and set deadlines, but just when do we, for instance, like when would you want to have plants? And have a goal kind of set for it.
All right, so our bill of materials includes all necessary items that will be used to build our hydroponic system. The table is labeled to include certain qualities and constraints to use to determine subsequently the best options possible for our system, and also what else we need to be considered, what we need to possibly use for our system. Also, we use the brainstorming process to eliminate certain options that we thought were necessary, in addition to using the book to sustain all other choices that we made. And throughout our bill of materials, you can also see our group's evolving mindset and certain products based on the qualities of certain qualities, such as ranking, cost, and the size that we actually needed for the system itself. And conclusively, we were able to limit certain options that we had available to us, such that we could have the most optimal solution possible for our initial goal.
All right, guys, we got the meter saw to cut the wood. We got the sawzall to cut the PVC piping. We got the PVC pipe cutter to cut the PVC piping, obviously. We got a tape measure to measure stuff. We got a speed square to angle everything, of course. We have a drill with like Phillips stuff. Of course, to assemble all of our pieces. Then we got Inventor to 3D model our system. And of course, we got some PVC primer and glue to put our system together if we aren't using screws.
All right, so our knowledge needed will be used to sufficiently give knowledgeable information on all aspects of the build and overarching concepts involved in the project. The skills and knowledge shown in our table are associated with the 3 STEM concepts, science, engineering, and math, that have been explained and evaluated for possible solutions, as well as the concepts associated with our knowledge acquired. Especially for the science and engineering aspects, we wanted to stress the importance of growth and development in the build itself in our project. But in general, we wanted to interconnect all foundational ideas to STEM, such as the knowledge and all things that we gained, such that we could find the best solutions for our virtual world that we're in right now. This includes the digital drawings we did in CAD, as well as our mentor's perspective on simulation that we could use for all elements of our project.
So basically what I updated was we obviously don't have the spiral anymore, so we don't have to worry about the coil. I updated the cost of our system because we were really lowballing it last time. I updated the height because obviously that's different. We have the plant trays, which are definitely different because we didn't have plant trays last time. The base, I assumed, is the same. The pump is the same. The lights work just about the same as we thought they would. And I think that's about it.
All right, guys, we got our subsystem tests. We got the water pump. We tested by putting it in the water, and then we made sure it pumped the amount that was prescribed on the box. We got our PVC pipes. We tested its structural integrity by putting Richards on it, as well as that we also had the wooden frame, which also was attached to the PVC pipes, and that was also tested by putting Richards on it. We got our grow lights. So of course we plugged them in to make sure that they were working properly and efficiently. And then finally, we got our bucket size reservoir. And this was the hardest test of all because all we had to do was just put water in it to make sure there were no leaks. All right, guys, for our testing standards, we got the water pump. It should be able to move the amount of water designated on its box. Should also be able to move our designated water up to about 6 feet. For our PVC pipe test, it should hold a lot of water, maybe about like a few gallons, and stay structurally sound. It should also transport the water fluidly without any like hitches or stuff like that. We got our wooden frame test. The wooden frame should be able to hold the PVC pipes and up to about 210 pounds, give or take 100. For our grow light test, the grow light should work as designated on their packaging and create a manageable amount of heat. And for our bucket reservoir test, the bucket needs to not hold any water, or rather it needs to hold water and not leak and not have any leaks. It should also be covered so there will be no algae blooms.
Alrighty, so if we ran into any problems during our testing, we're probably going to end up using my trusty dusty yellow notebook that I have not brought out of my drawers in 3 years until today. So yeah, that's practically how this design has been going. If anything was broken or didn't match any of the standards that we couldn't like deal with, we ended up writing it down in my notebook and spending 3 hours in a Lowe's cart. And yeah.
Okay, so obviously testing is an important part of the whole entire design process. So basically we use our subsystems as a guideline for the test that we were going to use and develop. And basically the tests that we developed, as we were kind of talking about already, were the PVC and wooden frame structure test, the water pump test, the reservoir test, as well as like testing our nutrient solution. And all these tests are just there to ensure that when we are ready to put our plants in the system, everything will be running smoothly as it should be.
Alrighty, so for our testing data, we've got 6 tests. The first one is a water pump test. It's to determine the amount of water loss over time. So we actually had no water loss as we are a closed system almost. And we ran that for 1.5 minutes almost. Next test is a reservoir test. Does light enter the bucket and create algae blooms? We put no, it does not allow water to pass through the bucket. Water flow, there's no leaks, there's no dead spots, we're good on there. PVC pipe structural test, it can hold up to 50 pounds, no permanent damage, no structural issues. Same thing with the wooden frame, as well as with our mixing nutrient solution. With 2 gallons of water, we put 256 ounces of nutrient solution, and that creates the pH to be a 6.2. And we cannot complete EC or ppm due to the fact that we don't have the testing kit yet.
So as you just saw our results, obviously what we kind of learned was just kind of how our subsystem works and making sure that all of them were functioning properly, and kind of just like if there were any problems, just refining them and making sure that everything is up to par with what we need it to be. Because obviously this is something that we're going to be putting in people's homes, so we want to make sure that it is good quality, and that's kind of what running these tests helped us to do, and we wanted to make sure that these tests were accurate, which we do believe that they are. And with the kind of like time constraints, we weren't able to get one of the products that we needed to test, like the ECC and ppm, which is still coming up, which we're going to do later once our products, our last product arrives. But as of what we have right now, our testing wasn't too extensive, but for what we need, it proved to be pretty good.
Pretty good.
So we have evolved our ideas and made the necessary modifications to edit our design to make it more conducive to our overall goals of being ergonomic and appealing. Some of these changes include the switch from our initial design of the spiral to the rectangular shape, which aids with the constraints to space that we have. Then from our current design to adding the necessary items we need for appeal and efficiency, such as the wheels, in addition to the need for lighting for plant development.